Welcome to the video tutorial that will review molarity and calculations using molarity. So for an introduction to solution concentrations, please see the introductory video. But we'll jump right into molarity. So molarity is represented with an uppercase M, which stands for moles of solute over liter of solution. So for example, if we have a 0.28 molar glucose solution, we can interpret this information one of two ways. We can see it as 0.28 moles of glucose per liter of solution, or we can write it out as a conversion factor, 0.28 moles glucose equals 1 liter solution. So as we've been learning, concentration units are very important because they link the solute to the solution. So there's two major types of calculations that you'll do with molarity, and the first one is to just quite literally calculate the molarity. So, folic acid is an essential vitamin and is linked to the prevention of neural tube defects in developing embryos. If 236 milliliters of orange juice, 1 cup of orange juice, contains 75 micrograms of folic acid, what is the concentration in molarity? So there's a lot of information here. Whenever we're working with molarity, it's very frequent that we're going to need to calculate the molar mass of a substance. So remember, to calculate the molar mass, we simply add up the individual atomic masses using the ratio of the chemical formula. And then here I've used micrograms, and remember in chemistry we'll use the Greek micro symbol, but professionally the micro is with MC. All right. So now let's get started here. So the first thing we're going to need is, if we have information in micrograms or grams and we're asked to go to molarity, we're going to need the molar mass. So along the margins of our paper, we're going to have 19 carbons, and the periodic table gives us the molar mass, 19 hydrogens, 7 nitrogens, and 6 oxygens. So the molar mass of folic acid, now that we have that set up, we can do the calculation. And so we see that the molar mass of folic acid is 441.45 grams per mole. So this is going to be a helpful conversion factor for us as we start our calculation. Now, we want to know molarity. So we want to get to moles of folic acid per liter of solution. In this case, the solution is the orange juice. So what do we know? The question gives us the mass of folic acid. So we have 75 micrograms, and folic acid we'll just abbreviate. And that 75 micrograms is found in 236 milliliters of solution, in this case orange juice. So now it's a matter of doing conversions. We need to get micrograms into moles, and we need to get milliliters into liters. So since our molar mass is in grams per mole, we'll do a metric conversion. There are 10 to the 6 micrograms in a gram. Now that we are in grams, we can bring in our molar mass, 441.45 grams in each mole of folic acid. And so now the first part is done. We have moles of our solute, folic acid. We converted out of micrograms into grams and used the molar mass to get from grams to moles. So we're almost there. Right now we have moles per milliliter, but we recognize that molarity is moles per liter. So we bring in one more unit conversion there that we're going to get from milliliters to liters. So we canceled out milliliters, so now we have moles of solute and liter of solution. Now that our units tell us we're done, we've done everything we needed to do, we can go ahead and punch these values into our calculator to get the final result. Wow, it's a very, right? So 7.199 times 10 to the minus 7 molar. Not very much folic acid. But now, the last thing we want to do is we want to check our sig figs so we can report the answer to the correct sig figs. So we see here with the 75 micrograms, we have 2 sig figs, 3 sig figs. Here we have infinite because it's defined. Here we have 5 sig figs, and here we have infinite. So our final answer, we want to report to 2 sig figs. So that would be 7.2 times 10 to the minus 7 molar folic acid. So it's amazing that such a small concentration can make such a big effect in the health of developing embryos. Now let's go to the next practice problem. So here we have ascorbic acid, also known as vitamin C, and it's a powerful antioxidant with the molecular formula C6H8O6. It helps the body form and maintain connective tissue, including bones, blood vessels, and skin. So if that same cup of orange juice contains 120 milligrams of vitamin C, what is the concentration in molarity? Right, so as soon as we see molarity, we think moles per liter, and we have milligrams of our vitamin C. So once again, the margins of our paper start to get filled. There are 6 carbon atoms. They each weigh 12.01 grams per mole, 8 hydrogens, and 6 oxygens. So we can punch these values into our calculator. And we find out that the molar mass of ascorbic acid is 176.14 grams per mole. Alrighty. So this question is very similar to the previous one. We were given a specific mass of vitamin C, 120 milligrams vitamin C, and our solution is the orange juice, 236 milliliters. So this time though, we were given our mass in milligrams, so we'll use the milligram to gram metric conversion, and then we use the molar mass of vitamin C to get to moles of vitamin C. And then last but not least, molarity is defined as moles per liter, and at this point, milligrams have canceled and grams have canceled. We have moles per milliliter. So we need one last unit conversion. There are 1,000 milliliters in a liter. So now we get rid of those milliliters and we're left with moles of solute per liter of solution. So the units tell us that we've performed all the necessary conversions. So now we can go ahead and punch these values into our calculator to get our final result. And so my calculator is giving me, let's see, right? 0.00289 molarity of vitamin C. And then once we finish the calculation, take a moment to look back at the sig figs. And once again, right, there's no decimal there, so 2 sig figs, 3 sig figs, infinite, infinite, right? These are infinite because they're defined by the metric system. And our molar mass has 5 sig figs, so our final result should be reported to 2 significant figures. So that would, and remember, leading zeros never count, so that would be 0.0029 molar vitamin C. Alrighty. So, molarity is moles per liter, and you want to be able, if you're given the mass of a solute and a volume of solution, you want to be able to calculate the molarity, recognizing that you'll most likely have to calculate the molar mass. But sometimes we're going to do calculations where molarity is going to be a conversion factor. So let's practice some of those. All right. So here, the molarity is given to us in the question, and we're going to use it to help calculate the final answer. So if a 0.28 molar glucose solution is isotonic with red blood cells, then how many grams of glucose are needed to prepare 500 milliliters of this solution? So this is the key part here, is when we get the molarity, we need to recognize what this is telling us. This is telling us that we have 0.28 moles of glucose in every liter of solution. Alrighty, so what's the question asking? So the question's asking us, how many grams of glucose do we need if we want to prepare the 500 milliliter solution? So we start with the volume of the solution we're trying to prepare. So we begin here, 500 milliliters of our solution. And now molarity is going to be the bridge from the solution to the solute, because we've been asked to determine how many grams of solute we need to add to these 500 mils. So we have a unit disconnect here. We have milliliters and liters. So if you can do this in your head, that's awesome. Otherwise, just go ahead, right? And there's 1,000 milliliters in a liter. So now we've gotten rid of the milliliters, and we're in liters. Now we can bring molarity. Molarity tells us that for every liter of solution, we need 0.28 moles of glucose. Alrighty. Now comes the last little bit. We need to go from moles of glucose to grams of glucose. So this is where we need to bring in the molar mass. So along the margins of our paper, looking at the chemical formula of glucose, there are 6 carbons. They each weigh 12.01 grams per mole, 12 hydrogens at about 1 gram per mole each, and 6 oxygens. So we add up all of those values. And we get the molar mass of glucose is 180.18 grams per mole. Alrighty, so now we can plug in the molar mass. Every mole of glucose weighs 100.18 grams. So let's check our units. We got rid of liters, and we got rid of moles, and so we're left with grams of glucose, which is exactly what the question was asking for. So since our units are showing that the calculation is complete, we'll go ahead and punch these numbers into our calculator. And the calculator spits out 25.225 grams of glucose. So then our last step is to report the correct sig figs. So here we have a decimal on this volume, so these trailing zeros count. Metric unit conversion defined. The concentration of glucose, only 2 sig figs, and the molar mass, 5. So the worst data limits our result. So we would only need to weigh out 25 grams of glucose to prepare the solution. All right, one last practice using molarity as in calculations. Okay, in this question we have, there are 3 grams of vitamin C available to prepare a 0.0852 molar solution. To what volume is the vitamin C diluted? All right, so this was a slightly different question. Let's focus on molarity. All right, so this is the concentration we want to prepare. So when we see this, we recognize that it's telling us 0.0852 moles of vitamin C per 1 liter of solution. All right, so that's what that's telling us. So this concentration will be the conversion that gets us from our solute to our solution. Now, in this example, we're starting with the solute. We've gone to the shelf and all we can find are 3 grams of vitamin C. So, we need to get to moles. On the previous page, we already determined that vitamin C has a molar mass of 176.14 grams per mole. So we're going to, whenever we have grams and moles in the same calculation, that should be a flag for molar mass. So we bring in the molar mass. Notice this time we're using it upside down, and that's fine because we can flip them any way we want. So we've used the molar mass to get the grams of vitamin C into moles of vitamin C. And now we can use the molarity concentration to convert. Now we're converting from the solute to the solution. So for every 0.0852 moles of vitamin C, we will have 1 liter of solution. So now if we look here, we started with grams of vitamin C. We converted those to moles, canceling out the grams. And then using our concentration, we cancel the moles of vitamin C, and now we have the volume of solution. And since the question didn't specify volume units, liters are a perfectly good volume unit, so we can stop there. So we will go ahead and plug these values into our calculator. And we see that we could prepare 0.1999 liters of solution. So we'll go back and look at our sig figs. 2 sig figs here. We count the 0 because of the decimal. 5 sig figs. And right here, leading zeros never count. 3 sig figs. So we're left with 2. So this would round to 0.20 liters of solution. Right? Or 200 milliliters. We'd have to put the over bar. All right, so we would take the 3 grams of vitamin C, and we would add 200 milliliters of water to create the desired concentration. So this concludes our practice with molarity. Now would be a great time to work on several homework questions related to molarity to reinforce your understanding.